Kia ora koutou. This is a complex numbers question for Zachary from a really old A-level paper. I'm just going to do the second half of it, but the first half is also worth looking at, but it's just a bog standard textbook question where we have to find the two square roots of this complex number. So you can either work in polar form or you can work in rectangular form. I would usually do this one just in rectangular form for this example. So we're going to said I wasn't doing that question. Kia ora koutou. This is a complex numbers question for Zachary, and it's just the second half of a question from one of the 2011 papers. And it's one where we have to find a locus and then do some stuff with it. So I'm not going to look at 10A, partly because I'm trying to watch the Big Sing finale concert at the same time as making this video. So I'll save that one for another day. But the part A problem is very kind of standard textbooky. The second part is a little bit different. So the key to doing well with this, as usual, is to do a really good sketch. So I'm going to start with just ruling up some axes. And then we'll read the question. Now, for A-level, you don't have to use algebra to do this question, and you really shouldn't. It's going to make it much worse. We have to shade the region whose points represent the complex number z that satisfy this inequality. So if I've got this form, suppose I've just got z minus 3i is equal to 2, then that's going to be a circle with a centre of 3i. So let's mark that on here, and a radius of 2. And I'm just doing this by eye, but we're going to draw, hopefully, quite a nice circle. Let's see how I go with that. Okay, not too bad. So that's my circle, and I have to shade in the region whose points represent the complex number when it's a weak inequality. So I need to shade in everything inside here. So that's the locus part, and I think that's probably worth maybe 2 marks. So we should just say on there that it's a circle with centre 0 plus 3i, and it's got a radius of 2. Now let's have a look at argz for points in this region. So I'm going to do this by taking my ruler, or my snapper card. So argz is the angle formed by the positive direction of the x-axis. So I'll just put a line on here to show you what's going on. So argz is this angle formed here, and you can see that it gets bigger as I move into the locus. So we can see the biggest value of argz is going to be over here. Let's just get rid of this. Okay, so this is what we're looking for, right? You can see that the greatest value of argz is where we've got the tangent is perpendicular to the circle. So we might write that down. So the greatest argz is at point, let's just call it point A, where the tangent is touching the circle. Kia ora koutou. This is a very short video for Zachary looking at a good complex numbers problem from back in 2011. I'm just going to do question 10b here, which is a locus problem. So we have to sketch an argon diagram and shade in the region whose point represent these complex numbers. And then we have to find the greatest value of argz for points in this region. Now, Zachary asked me, he said he could do it, but he couldn't do it with algebra, and that's fine. But what you do need to have is some pretty clear logic just written out and a really good graph. Problems like this are often the harder ones in the complex numbers loci questions, and once you get the hang of them, they're not too bad. So let's have a look and just rule up some axes. Here we go. So the locus, when we've got z minus 3i is less than or equal to 2, is going to be a circle, because it's the distance between this complex number z and this complex number 3i. So the centre will be at 3i, and we're going to have a radius of 2, and we're going to shade in everything that's there. So let's just go up 1, 2, 3, up to here, 3i here. Let's go up another 2 here, out a couple here. Look, I should be doing this properly with a ruler, but I'm trying to watch the Big Sing finale and waiting for WC and WC to be on. So that's why I'm doing this a bit sketchily. Let's see. I'll just put a circle on here nicely. Right, there. How about that? It's a shame you guys can't do that in the exam. There we go. There's my nice circle. Okay, so we're going to colour that in, and that's going to be the locus that I'm after. Right, so the centre here is at 3i. And we know that to form arcz, what I'm going to do is take a ruler, and arcz is the angle that's formed here between the positive direction of the real axis and wherever I am. So we're just going to move that ruler around, and let's see where we're going to get the greatest value of arcz. Well, you can see the smallest value of arcz would be there, right? That's where it just starts to touch. And as we move it round, you can see that the greatest value of arcz is going to be on the other side over here. So let's get rid of the smallest one in that line. So that the argument that I'm looking for is this angle in here. Right, so the greatest value of arcz is at point P. Right, so point P is where the line from 0, 0, or 0 plus 0i is tangent to the circle, and I might just say in quadrant 2 or something like that. Okay, so you might have looked at this question and thought, well, maybe what I need to do is to figure out the equation of that locus, right, which is going to be x squared plus y minus 3 squared is equal to 4. And you could think, well, maybe I have to differentiate it or do something like that, and you definitely don't want to go down that path, right? What we want to do instead is go back to year 10 or 11 geometry and remember that the tangent is always perpendicular to the radius. So if we take our ruler and we can plonk on a line here, we know that we've got a right angle here. This is my centre here. And so we've got a little right angle triangle that's formed. And if we're looking for theta here, which is the argument, it's going to be, oops, I don't know what just happened there. Look, guys, usually I would just remake this video, but I really want to get this done before I have to go watch Big Sing. Okay, let's try again. Okay, here are my axes. And here's my locus one coming in. Okay, so we want to find this angle in here. This is going to be theta, and then we're going to add 90 degrees onto it. But we know a few things here, right? We know that this length here must be 2, and we know that this distance here must be 3, because I'm going from the origin up to 3i. So I've got a little right angle triangle, which looks like this. Here's my right angle, this is my distance 3, and this is my distance 2. So just going back up to the graph, you can see that I've just tipped that whole picture around on its side. This is my angle here. So this side here by Pythagoras will be the square root of 9 minus 4, which is root 5. So tan of theta, or I could use any of them, but let's just do tan. Tan of theta is 2 on root 5, which gives me theta is equal to 41.8 degrees. So the greatest arcz will be 90 plus that. 41.8 degrees plus 90 degrees, which gives me 131.8 degrees. There you go. I'll do the first half of that with the finding the square roots later on if anyone sends me an email and says they want me to do it. Thanks for watching.